Calculations time with Dr. Dave. So today we're going to be talking about ratios and proportions. So let's begin talking about what is a ratio. So when we're talking about a ratio, we are talking about a relationship between two or more things. So for example, if I was to tell you that we have one person, Jane, who has $1,000 to spend on a shopping spree, and we have her friend Bill that has $200 to spend. What type of relationship can we make between those two values, the 1,000 and the 200? We can do one which is saying that Jane has 5 times more money to spend than Bill, right? Because 5 times 200 will be 1,000. We can also put them in a ratio. So it's like this, so that one is divided by another. And I think from math, most of us are comfortable with reducing that so that it would equal the 1/5. Now you can also say it verbally or write it verbally. You can say that there is a 5-to-1 relationship, right? Because Jane has 5 times more than Bill. Or you can also state it this way, with the semicolons between it, 5-to-1. So if you see this 5-to-1 written this way, notice it is the same thing as writing it as a fraction, so don't get tripped up by that if you do see that. So let's take a summary really quickly. We know that we can write the ratios as a fraction. You can also say it or write it this way, or you can use it as a semicolon 5-to-1. So instead of writing it out, you can use the semicolons for it. Keep in mind that a ratio is a relationship between two things, and in pharmacy calculations, we typically are looking for some type of relationship between two things, and we're going to relate that to another. So for us here, also keep in mind that if you do see it like this relationship between one number and another, you could see it as whole numbers, but you can see 4-to-1. So for example, this is a ketogenic diet, right? That is high fat and low carbohydrates, and they have the fat to carbohydrate ratio 4-to-1. But they also tested one which is 2.5-to-1. So notice, it doesn't have to be a whole number in the beginning. It can be 4, 3, 2, 1, or it can be portions of that. So 2.5, 2.2, 2.7, whatever it is, to 1. When we have a ratio, so if we do have a ratio that we've established and we set it equal to another ratio with an equal sign, then we're now dealing with proportions. And most of us have seen some proportions, even if you didn't call them proportions, but we usually see them this way, where you have one fraction equal to another fraction. So for example, 5-to-1 is equal to 10-to-2. And usually we've gone this way where we're reducing those fractions. Notice again, we can also use it the same way before that we learned above. We could do that 5-to-1 or 10-to-2, taking the same concept that they are fractions and reducing them. So when we set the relationship equal to each other, we call it a proportion. The reason why we go over this and why it's important is that typically in calculations for this course, we're missing some number. So if the 2 was not here and I asked you, you had 5-to-1 is equal to 10 as to what, you'd be able to solve for the remaining fourth unknown. So if you have 3 known and 1 unknown, you'd be able to solve for that. Now most of us are familiar with setting up these proportions and solving for them. So let's take an example right here. If I told you that 10 prescription bottles cost $25, how much would 6 prescription bottles cost? So if 10 of them cost $25, how much do 6 cost? You first are looking for the relationship, the ratio of something that's given. So you want something that you have 2 numbers that are given. And notice we have 10 prescription bottles cost $25. So we can write this ratio. $25 is for 10 bottles. That's the relationship. We're trying to find out X number of dollars, right? This is really dollars here. X number of dollars. That's for 6 bottles. This is typically the next step most people do. They say they cross multiply. So they multiply 25 times 6 and they multiply 10 times X. So they get 25 times 6 and that equals to 10x, and then they solve for x, right, by dividing by 10 over here, and that equals the x. Now, that is fine to do, but there's two things to be familiar with. One is there is no such thing as cross multiplication. That was a cheat thing that we learned. What we're really doing is we are multiplying, if I can erase this here. So what's really happening to solve this is that we are multiplying this side of the equation by 6 bottles, right? And we're multiplying this side of the equation by 6 bottles. We can't cross multiply because there's no such thing as multiplying across an equal sign. So that's why we are multiplying each side by 6. We're isolating the x, and then we get our answer that way. Same exact thing, it's just the way in which it is really done and not the cheat thing that we're doing by cross multiplying. For pharmacy calculations, time is usually on your side, as well as keeping track of units. So there is a way to do this so that you're eliminating multiple steps, and you're usually doing it in one setup and then one calculation. So let me show you how that same problem will look down here. Right? If you have $25 is for 10 bottles, you're going to take that ratio and you are going to put the value that you need the units of on top. So for example, I'm asking you how much 6 bottle costs. So that's a dollar value. So in my ratio that I have the two things here, the 25 per 10, I'm going to put the money value on top, which means the $25 is going to go on top and the 10 stays on the bottom. Then I'm going to multiply by the number of bottles, and you'll notice that when I do that, the bottles will cancel out and I'm equal with my $15, which is the answer, which is the unit that's here, matching the unit here. This is exactly the same thing that happens over here. Notice this is 6 times 25 over 10. This is 6 times 25 over 10. Same exact thing that I'm doing here, right? So this thing is the exact same thing that I'm doing here. I'm just doing it in one step. The reason why I'm teaching you this is that if you learn to do it this way over here, you will have a quicker way to do it. You will also be able to cancel out these units as you move forward with more ratios. And you also will understand that when you do this, this first value that you're getting, this 25 over 10, anytime you take some number and you're dividing it by another one, you are getting per one. So what does that mean? That means that you are finding out the dollar value, right? So you're finding out the dollar amount per one bottle. So in your calculator, when you take 25 and you divide it by 10, that is the amount per one bottle. And then you're multiplying that amount by 6, which is why you get 15. So keep in mind that when you're doing this, you're getting per one. So you're really finding out the dollar value for one bottle, and then you're multiplying it by 6. Kind of makes a little more sense mathematically when we talk it verbally than some people will find when they do it this way. All right. So in order to do that, again, you always find the ratio that you have and you keep the units that you're looking for in your answer on top. So let's try one that has a little more pharmaceutical example associated with it. So if we have 3 tablets and they contain 975 milligrams of drug, how many milligrams will there be in 12 tablets? So the first thing that we always have to recognize in these problems is really the ratio. Remember, you're always digging around trying to find ratios. So we have a nice ratio here. We have a number 3. We know that 3 tablets contain 975 milligrams. So I can put 3 tablets, right? It has 975 milligrams. Or I'm either going to have 975 milligrams and 3 tablets. I can write that either way. But for the way that I just taught you, you want to put the numerator with the units that you're looking for. I'm saying how many milligrams will be in 12 tablets. So which one of these has the milligrams on it? This one or this one? This one has milligrams. So I'm going to get rid of this one, and I'm going to keep it the way that it is. So I have my ratio 975 milligrams is per 3 tablets, right? And it says how many milligrams will be in the area in 12 tablets. So then I'm multiplying this by 12 tablets. Notice the tablets is going to cancel out. I'm going to be left with milligrams in my answer. And keep in mind again that this value here, when we take 975 and we divide by 3, that is telling me the amount of milligrams in one tablet. and then I'm multiplying that by the 12. So this answer, when we do it out, will be 3,900 milligrams. If you are comfortable first doing it this way, where some people want to do the 795 milligrams is equal to 3 tabs, and they're like, how many milligrams is there in 12 tabs? You're doing the same thing again. Remember, you're multiplying by 12 on this side, you're multiplying by 12 on that side, and that's what was happening up here. We're just doing it in one step. Getting very comfortable with doing it the top way will save time, as well as clearly be able to let the units cancel out. All right, let's try one more. This one says if 30 milliliters represents 1/16 of a volume of a container, how many mLs would represent 1/4 of the container? Now, different ways to do this. I find that the easiest one would be to convert. So you're going to convert that 1/4 and 1/6 into fractions. So you can do that, and now we have a ratio that we can easily put. Now, I had a lot of room down here, but I'm going to right outside of this box. So I get my ratio. I have 30 mLs, right, is 1/6 of a volume, and 1/6 is 0.167 approximately, right? So if 30 mLs is 1/6 of a volume container, how many mLs will be represented by 1/4, or 0.25 of a container? And I'm putting the mLs on top because that's what I'm looking for in my answer, how many mLs. And when I do this out, I'm going to get about 44.9 or so. This is approximately about 45 mLs is what I'm going to be left with when I do my answer. There are other ways you can do this by keeping the fraction the same. So you can keep the 1/6 and the 1/4, utilizing them, and get the same answer by using those in the fractions. All right, so that is ratio and proportions. And as always, this is Dr. Dave telling you that pharmacy calculations is the most important subject because it's the only one that counts.